I want to show you how to divide decimals, but before I do, I'm going to have to make sure that you understand the vocabulary of the words that I'm using.
Throw me a frickin' bone here. I'm the boss. Need the info.
Remember division vocabulary. When we have a problem like this, 42 divided by 7 equals 6, we call 42 the dividend. He's the guy getting divided. 7 is doing the dividing, so he's the divisor, and the answer is the quotient. Now you may see this problem looking a little bit differently when we do long division. We say that the 60, for instance, is in the jail, if you would. We still have the same three numbers, though. 60, the guy getting divided, is the dividend. The guy doing the dividing, 2, is the divisor, and the answer to a division problem is the quotient. When we actually performed long division on whole numbers, we remember that we went through the same sequence of steps, sometimes several times. We began by estimating an answer, or a quotient. Then we multiplied our guess times the divisor to see what we were off by. Of course, to find what we were off by, we subtracted, right? And once we had subtracted, we brought down the next digit and went back and went through the whole sequence all over again, re-estimating an answer, or a quotient, re-multiplying to check our accuracy, once again subtracting, and once again bringing down the next digit. And we kept bringing down the next digit until there wasn't one. So we went through this sequence of steps over and over again to do long division of whole numbers.
Allow me to demonstrate.
Let's look at one. I asked myself, how many times does 3 go into 2? Well, it doesn't. It goes in nonce, huh? So I could write a 0 there, but I'm not going to. I'm just going to continue on and say, how many times does 3 go into 25? Well, 3 does go into 25 8 times. So note where I write the 8 above the 5 of the 25. So I'm showing that I'm dividing into 25. So I made my guess. Now I multiply 8 times 3. I get 24. The next step is to subtract. 25 minus 24 is 1. And finally I bring down the next digit, which in this case is a 4. Now I go back and start the process all over again. 3 into 14, well, that goes 4 times. So I write the 4, multiply 4 times 3, subtract, and I do have another digit, so I bring it down. And I start the process again. I make a guess. 3 into 21, well, it goes in 7 times, so I write the 7, multiply 7 times 3, subtract to see what I'm off by, and then perhaps bring down the next digit. But there isn't a next digit, so I'm done. So that's the process. Note we go through the same sequence over and over again until we do not have a next digit. And that'll be my answer.
And now, ladies and gentlemen, let's get ready to rumble.
Well, let's use these same principles dividing decimals. To divide decimals, we're going to position the decimal point to the right so that, remember who the divisor is, so that the divisor is a whole number. We have to keep the divisor happy. He's the guy who's doing the dividing. Of course, we have to be fair. So if we move the decimal point over for the divisor, we have to move it over the same number of decimal places to the right of the dividend as we did for the divisor. See why we need to know these words. And then we just divide decimals as though they were whole numbers.
Let's play. Here we go.
Let's try it. I'm going to position the decimal point to the right, whatever number of places that I have to keep the divisor, which is the guy doing the dividing, a whole number. I see the 4 needs to have the decimal place moved over one place. So I'll have to do the same for the dividend. Now, so I'll remember where it goes, I'm going to put it up where the quotient or answer goes. Now I just divide normally, considering that everybody, well, at least we'll pretend everybody is a whole number. Okay? 4 into 33 goes 8 times. I make a guess. Multiply. 4 times 8. Subtract. And bring down the next digit. Now I make another guess. 4 into 12 goes 3 times. Multiply. Subtract. And son of a gun,
You are correct, sir.
I've got the answer.
Thank you, sir. May I have another?
Let's look at another example. It's all going to be the same, though. I'm going to have to position the decimal point to make sure that the divisor, the guy doing the dividing, is a whole number. Now, in this case, as you can see, I'm going to have to move it over 2 places. So if I move him over 2 places, I'm going to have to move it over 2 places for the dividend. And I'm going to right away, because I'll forget, I'm going to put it up where it is right now in the answer. And now, just forget that they're there and do the division. 5 into 22 goes 4 times. I make a guess. I multiply. I subtract. Bring down the next digit. 5 into 25, make a new guess. Goes 5 times. I multiply. I subtract. And I bring down the next digit. But there isn't a next digit.
Oh, no.
So I've got an answer. The answer is 4 5/10. Now, there are some tricks. Hopefully you remember about multiplying, so there's going to be some tricks about dividing. Recall that when we multiplied a decimal by a power of 10, we could have done it in 2 steps. In this case, we could have added 1 0 because we were multiplying by 10, and then, of course, we would have had to move it over the number of decimal places 3. We would drop the 0, wouldn't we? But we could also use the shortcut that we really moved it over 1 place. To multiply by 10, we moved the decimal over 1 place. By multiplying, it was to the right to make the number a larger number. In this example, we're going to have to add 2 zeros, and in this case, move it over 3 places. Drop the zeros. And I hope you note, to multiply by 100, the final result was to move the decimal place over 2 places. So that was a nice shortcut when we multiply by some power of 10.
Excuse me, Professor Brainiac.
Okay, here's the shortcut. You move the decimal place to the right the same number of places as there are zeros in the power of 10. That's multiplying by powers of 10. Remember, though, we're moving to the right because when we multiply, the number should get bigger. And if we need to, we can add zeros. Well, what does that have to do with dividing? Well, we can use the same shortcut to divide as we do to multiply, except with multiplication, the number is going to get larger, so we're going to move the decimal over to the right. With dividing, we're going to do just the opposite. We're going to move it over to the left, because division should make it a smaller number. So to divide by powers of 10, you're going to move the decimal point to the left the same number of places as there are zeros in that specific power of 10 that you're dividing by. Remember, when you're dividing, the number should get smaller, so you'll move to the left. Let's try some. I'm going to mix them up to keep you honest. In this first problem, we're going to go to the right because we're multiplying. Now, how many places are we going to go to the right? We're multiplying by 100, 2 zeros. We'll go over 2 places. And the answer will be, let's see, 23,945 and 2/10. We just moved over 2 places to the right. In this problem, it's very similar, but we're dividing. So we're still going to move over 2 places, but we're going to go the other way. And the answer, quite quickly, will be 2 and this decimal. It's a lot of numbers, isn't it? In this case, we're going to divide, so we're going to get smaller, but we're only going to divide by 10. So we're only going to move it over 1 place, aren't we? And there's your answer. Now don't forget, when you divide, you move to the left to get smaller. When you multiply, we're going to move to the right, the same number of zeros that are in the power of 10. Now if we move all the way over to the right, we're going to have a whole number, and we usually don't write the decimal point for a whole number. So just write it like that. In this case, we're going to move over to the left because we have division, and our answer will be a very small number. It's very simple, isn't it? How about some challenging ones? Yep, we know we're going to go to the right on this multiplication problem because we want the number to get larger. But we need to move over 3 places. We don't have 3 places. Do you remember what you do? We're going to have to add a new digit, which will be a 0, and that'll be your answer. And the same thing happens with division. Now in this case, we're going to move to the left because it's division, but we need to move over 2 places. But we don't have 2 places. So we're going to create another place by adding a 0 in the appropriate spot. And that will be your answer. So sometimes you're going to have to add zeros. In this case, we're going to go to the left 3 places. So we're actually going to have to add 2 digits this time. We have 1, we need 2 more. And that'll be our answer. Got the idea? Well, go practice. Try the homework.